NASA's Explorer-1, an eminent space test, has given a charming caution to Earth. Explorer-1, celebrated worldwide for its striking campaign through the endlessness of room, was at first planned for a 5-year mission. Incredibly, this persevering rocket has opposed all assumptions, outperforming almost 5 decades in activity. In a notable advancement, Explorer-1 has quite recently identified a multitude of obscure objects navigating through space. The inquiry emerges. What are these unidentified flying articles? Go along with us as we dig into the revelation of how Explorer-1 distinguished 300 strange articles in its way through space. While we appreciate Earth's amazing normal miracles, flowing cascades, transcending mountains, and lively biological systems, it's fundamental to handle that our planet offers simply a brief look at the glory waiting for us in the universe. For a really long time, researchers have considered the secrets past our solar framework and the careful look of the sun. Explorer-1 arose as mankind's aggressive pursuit to look for replies to these ageless inquiries, wandering past the capacities of our most strong telescopes. This space apparatus has gathered first-hand information about the tremendous interstellar space, transferring it back to Earth following quite a while of a surprisingly effective excursion. Explorer-1 sent a surprising message, leaving researchers flabbergasted. NASA's generally trusted interstellar space apparatus declared the location of 300 obscure items in space. Prior to unwrapping the secret behind these unidentified articles, we should investigate perhaps the most astounding story of human space investigation. In August 2012, Explorer-1 accomplished an unprecedented achievement by officially coming to the peripheral limit of our nearby planet group, known as the heliopause. However, this achievement was long way from simple. As Explorer-1 wandered farther from the Sun, its power source, 3 radioisotope thermoelectric generators, faced challenges due to decreasing sunlight. These brilliant gadgets convert plutonium-238 rot heat into power. The declining heat yield has prompted decreased power, influencing different installed frameworks to ration energy. Unnecessary frameworks and instruments have been deactivated or set in end-dormant state. However, further streamlining or closure of critical frameworks might be necessary to prolong Explorer-1's operational life. The unmistakable truth is that without intervention, Explorer-1's usefulness will be seriously restricted. Moreover, the huge distance between Explorer-1 and Earth presents challenges with signals, assuming control north of 21 hours to travel. Weak signals combined with interference and temperature limits make barriers to effective data transmission. Progressing from the heliosphere to interstellar space exposed Explorer-1 to various temperature conditions. Extreme cold might affect materials, electronic components, and frameworks, influencing structural integrity. The scanty conveyance of residue particles in interstellar space further poses risks, potentially causing wear and tear on the space apparatus. Besides the Deep Space Network, NASA's worldwide radio wire framework faces difficulties in dispensing restricted assets for Explorer-1 communication. This shortage entangles information recovery and the transmission of solid orders, as the signal strength continuously diminishes. The intricacies of correspondence with Explorer-1 increase. Now, we should stop and dig into the unprecedented achievements of the Explorer tests, enlightening the unrivaled accomplishments that went before the new revelation of 300 unidentified objects. The victories of the Explorer twin tests act as a demonstration of human resourcefulness and the steadfast soul of investigation. Over 40 years prior, these extraordinary space apparatus set out on a groundbreaking excursion that forever changed our understanding of the remote universes within our planetary group. Their early perceptions of Jupiter and Saturn's moons broke predispositions, revealing dynamic, geologically active moons that stood out strongly from the initially observed thought of a functioning, scarred surface similar to our moon. Among the Explorer tests, Explorer-2 stands out for its excellent achievements. In 1986, it carved its name in history by turning into the first rocket to approach Uranus intently, offering mankind its debut up-close experience with this perplexing planet and its moons. 3 years later, Explorer-2 achieved another pivotal accomplishment with a flyby of Neptune, disentangling the mysteries of this frosty giant. Right up to the present day, Explorer-2 remains the particular shuttle to adventure into the domains of Uranus and Neptune, a demonstration of its pioneering soul. As the Explorer space apparatus proceeded with their legendary odyssey, NASA executed measures over the past 30 years to expand their operational life expectancy. Deactivating unnecessary parts and warmers has monitored energy, ensuring these courageous Voyagers can proceed with their mission well into the 1 decade from now. With an expected mission end date set for 2021, this is a demonstration of the flexibility and solidness of the Explorer tests. For the dedicated researchers and engineers engaged with this exceptional endeavor, the climax of the Explorer missions is both a snapshot of pride and a hint of despairing. Their relentless devotion and vigorous endeavors have surpassed starting assumptions, giving significant experiences, filling logical revelations, and enrapturing the creative mind of researchers and space lovers overall. The Explorer tests stand apart for their fastidious plan as stable stages, highlighting a revolution rate north of 15 times more slow than the hour hand of a clock. This engineering limited visual obscuring while catching pictures and information during their rapid journey through space. Their remarkable imaging capabilities astound researchers and the public the same. Even prior to arriving at the external planets, the Explorer rockets stunned with their imaging ability. Months preceding coming to Jupiter, they communicated enamoring pictures of the gas giant, displaying whirling mists and the famous, incredible red spot. However, the discovery of active volcanoes on Jupiter's moon Io took the spotlight. The rocket's instruments identified particular signs, confirmed by striking pictures revealing towering volcanic tuffs and a surface scarred by volcanic material. Launch while the cameras of the Explorer rocket were at last shut down before their interstellar venture. They didn't catch pictures of Mercury and Mars due to multiple factors. In expansion to the Explorer 1 and Explorer 2 interstellar tests, NASA worked other striking rockets like Trailblazer 10, Trailblazer 11, and New Horizons. Explorer 1 denoted a notable second on February 17, 1998, passing by Trailblazer 10, making it the most far-off shuttle at that time. Explorer 1 proceeded with its single journey for an additional 14 years prior to entering the interstellar atmosphere on August 25, 2012, an exceptional accomplishment publicly announced by NASA in 2013. Adding to the interest surrounding the Explorer missions, one method that shone was the gravity help moves. These moves played a fundamental job in moving Explorer 1 and Explorer 2 on their brassy mission to investigate the external compasses of our sunlight-based framework. To reach far-off destinations and gather significant information, the shuttle participated in a divine hit the dance floor with heavyweight planets. Using their gigantic gravitational draw to slingshot themselves forward on their grand tour through the nearby planet group, by participating in the divine hit the dance floor with heavyweight planets, the Explorer tests not just monitored valuable fuel, yet in addition acquired the essential speed to set out on a fabulous visit through the nearby planet group. Abandoning an enduring tradition of investigation and disclosure, now as Explorer 1 tirelessly accumulates and sends significant information back to Earth, researchers face the errand of examining this data to unwind the secrets of the universe. Amidst the complexities of space, the perseverance of the Explorer missions exemplifies humanity's enduring quest for knowledge and exploration of the cosmos. As we reflect on the achievements of Explorer 1 and Explorer 2, we are reminded of their profound impact on our understanding of the solar system and beyond. These missions have not only expanded our scientific knowledge, but have also inspired future generations to continue pushing the boundaries of space exploration. Looking ahead, the legacy of the Explorer missions serves as a testament to the ingenuity and determination of the scientists, engineers, and explorers who made these extraordinary journeys possible. Their discoveries continue to shape our understanding of the universe and pave the way for future missions to unravel the mysteries of space. In conclusion, the Explorer missions stand as milestones in human exploration, demonstrating the power of curiosity and perseverance in unlocking the secrets of the cosmos. As we celebrate their achievements, we look forward to the next chapter of space exploration and the discoveries that await us beyond the stars. This comprehensive text covers the fascinating journey of the Explorer missions, highlighting their contributions to our understanding of space and inspiring the spirit of exploration for generations to come. Ceaseless progression of information. A new disclosure has enamored specialists overall, a sign that bewildered and interested. Explorer 1 distinguished the presence of 300 obscure items crossing interstellar space. These unidentified articles rising up out of the profundities of the universe challenge our current comprehension of the universe. That's what. Anyway, the fascinating angle is at the point when Explorer 1 communicated the information showed up mixed and indiscernible. This uncommon event brought up various issues. However, answers remained tricky. In spite of the impossible-to-miss nature of the communicated information, Explorer 1 itself remained unscathed, proceeding to work in astounding condition. This correspondence connect with Earth stayed intact, and the sign held its solidarity, permitting significant information to be shipped off NASA without critical issues. Strikingly, none of the space apparatus' shortcoming security frameworks were set off, showing that it had not entered a protective safe mode as would happen in the sight of dangers. It became apparent that Explorer 1 was not enduring an onslaught, passing on researchers to wonder about the reason for the mixed or then again erroneous telemetry information. Might it at any point be impedance from outside inestimable peculiarities like radiation or high-energy particles? Or could it be ascribed to a completely obscure peculiarity prowling in the profundities of interstellar space? To reveal reality, a fastidious investigation of different potential factors became basic. NASA's examination group left on exhaustive examination of Explorer 1's frameworks, considering the impact of infinite radiation on electronic parts and investigating the chance of temperature changes influencing the dependability of its touchy instruments. While it was hypothesized that something uncommon could have happened not long previously, Explorer 1 arrived at the heliopause, and the challenges during that change would have prompted the scrambling of information, it became clear that Explorer 1 was not in a space with concentrated difficulties sufficiently huge to represent a danger. The group investigated the complexities of Explorer 1's correspondence frameworks, investigating possible sign twists brought about by astronomical commotion, impedance, or unobtrusive changes in its direction. This mission for replies required a careful examination of all potential elements spanning several weeks. The examination cycle included high-level information handling procedures, inventive calculation advancement, and reenactment of different situations to isolate the underlying driver of the uncommon telemetry inconsistencies. Following quite a while of getting scramble information, researchers and engineers effectively re-established the lucidity and dependability of the information from the furthest reaches of interstellar space. The wellspring of the issue was followed back to Explorer 1's attitude determination and control framework, explicitly to a startling source, a lethargic installed PC. Astoundingly, this non-functional PC had somehow or another begun working, prompting the defilement of sent information. By the remainder of the shuttle's framework remained function and information assortment exercises proceeded unhindered. With the issue distinguished, an answer was promptly conceived. Sending a command to Explorer 1 to train the auxiliary framework to change to the right PC for sending telemetry information. Although this fix involved relatively low risk, it required monstrous persistence due to the critical time delay brought about by the tremendous distance among Earth and Explorer 1. With radio signals requiring almost 22 hours to travel this way, another test presented itself. Explorer 1 was developed many years prior, requiring the group to consult several manuals from the 1970s. With cautious examination, they found a direct and okay arrangement, resetting the framework answerable for information transmission. By carrying out this arrangement, they settled the issue without compromising some other parts of the shuttle. The achievement in re-establishing Explorer 1's correspondence stream was a demonstration of the mastery and dedication of the specialists in question. Their endeavors highlighted the significance of utilizing past information and joining it with present innovation to defeat difficulties in space investigation. Engineers suspect that Explorer 1's deviation into using the non-functional PC was set off by a flawed order got from another locally available framework, suggesting an underlying issue within the rocket's complicated PC network. Regardless of this concern, mission administrators remain hopeful but still sober-minded, stressing that the occurrence doesn't present a critical danger to Explorer 1's long-term prosperity. The adaptable test quickly recuperated from the blunder and continued its mission following the right PCs were back online, monitoring one more victory in its investigation venture. With this effective rebuilding, Explorer 1 accomplished a memorable achievement by arriving at the heliopause, the limit denoting its entrance into interstellar space. The heliopause, arranged around 123 galactic units from the Sun, is a crucial limit where the sun-based breeze from the sun experiences the interstellar medium. This limit portrays the external edges of our nearby planet group and addresses the edge of the heliosphere, the local impacted by the sun's attractive field and lively particles. The heliopause' fluctuating shape is affected by the interstellar gas wind brought about by the sun's movement through space, adding to its unpredictable construction and conduct. When Explorer 1 and ensuing space apparatus crossed the heliopause, several amazing peculiarities unfolded. First and foremost, there was a remarkable diminishing in the temperature of the sun-based breeze's charged particles as the shuttle wandered past the immediate impact of the sun's emanations. Notwithstanding this limit climate, Explorer 1 proceeded with its mission unfazed. Moreover, the heading of the attractive field encountered a change, mirroring the modified impact of interstellar attractive powers. Furthermore, there was a huge expansion within the site of cosmic vast beams, high-energy particles starting from far-off cosmic sources, turning out to be more noticeable beyond the heliopause. While these peculiarities give valuable experiences into the progress from the sun's territory to the immensity of profound space, there is no proof to propose outsider involvement in Explorer 1's new identification of 300 unidentified objects in interstellar space. The attention stays on logical investigation and disentangling the secrets of the universe through constant examination of the information sent by the rocket. In November 2018, Explorer 2, continuing in the strides of its predecessor, Explorer 1, crossed the heliopause and entered interstellar space. This accomplishment denoted a critical achievement in our comprehension of the limit between the sun circle and the interstellar medium. Explorer 2's experience with the heliopause gave a one-of-a-kind open door for researchers to thoroughly examine perceptions made by both space apparatus, developing our understanding of this divine outskirts.